chat is still there. I don't think we are. That's a problem, but.
Okay.
We are live, guys. From now.
You are live. It seems perfect.
Okay,
we can try to share your desktop. Yeah.
But can you see? Do you see the chat on? Okay, just 1 second. Hello, everyone. We are doing some quick tests now before we get started.
Hello, everyone.
Okay, Maurizio, I just started the screen sharing. Can you confirm, Maurizio, that the screen sharing is working?
Yeah, see your smartphone for more info.
Okay. Okay. Is it possible to disable the chat? Do you still see the chat on the right side?
Yes, this chat is still present in YouTube and in ClickMeeting.
Okay. Maurizio, can you also turn off? Can you please turn off the microphone, Maurizio? Okay.
Aslı.
Okay, Hamid, we are almost ready.
Okay.
Okay, let me check if everything is working also on YouTube. We are still live on YouTube.
Okay, nice. Shall we start?
I think so. I think that we can start. Yeah. Okay, just 1 second. I come back to my interface. Okay, perfect. Okay.
Okay, great.
Ready. Thanks, guys, for the patience, but we have really an incredible reaction. I mean, a great audience today. We are more than 2,000 people connected. So managing all this system, we are doing the live stream to YouTube is like very challenging. We hope that everything will work for these 2 hours of event.
Okay.
Well, first of all, I want to say thank you to everyone for the overwhelming attention that we received. I want to thank also the Click Meeting team that is supporting us through this direct. They also enlarged this room in order to give possibility to many people to reach us today. And well, I'm very happy to be here, and I'm here with my friend Hamid. We decided to do this event for many reasons. Hamid, would you please introduce yourself, and I mean say your point of view on also on this situation, on this event that we organized together.
Hi, everyone, and hi, Arturo. Thanks for inviting me to this event. And thank you so much for joining this event. We wouldn't expect this much of attention. Almost at the first hour, we just filled up the whole meeting room of the Click meeting, almost 100%. And now we're live with 2,000 person. So
yeah, I think also more. They're growing. They're growing. So maybe more.
Okay, and yeah, more than 2,000 people on YouTube Live, and this in this tough times of being and staying at home and keeping it safe. We just thought maybe we can add some value to those people to help from the things that we have in our hands, from the knowledge that we have in our hands. Maybe we can do with our own part by sharing this information with you designers, with architects, whoever is interested in learning, and maybe we can just help to pass this epidemic crisis by doing these kind of live videos.
Yeah, absolutely. I agree with you. And well, actually, the first thing that I'd like to say is like, why this event? And the title actually that we decided to put, the subtitle in a way, is Horizons, because when we had our first chat, we were talking about this kind of, we were missing, and you know, in Italy the situation right now is critical, is very critical. There is this lockdown, and we must stay home in order to prevent the contagious spread. So I was feeling this kind of, I was missing horizons physically, but also this is also a metaphor to say that also in terms of perspective. And now probably parametric design won't change and won't save the world, but we had a lot of discussion about that, and we strongly think that parametric design as an umbrella definition is a kind, I think that we see in parametric design a kind of convergence of ideas, intuitions, of interest from people. There are many people that daily, that every day, and you know it well, thanks to your parametric architecture Instagram page, people, they find inspiration and a reason also in a way for going on in their research and study. And so that's why it's important, and we both felt a kind of, let's say, responsibility, but also we want to really give a kind of strong and optimistic message, because we strongly believe that behind parametric architecture, once again, this is not the context to define what parametric architecture or parametric design is, but once again, as an umbrella definition which gathered together many ideas and inspiration, I think that we are giving, and we really want to give an optimistic points of view, and trying to be inspiring for people that right now they are at home and they want to go on in their study, research, and so on. So I strongly believe that this is that we want to give an optimistic message. We also got a lot of questions from people. We both from our different Instagram pages. There are questions that are basically focused on on like there are questions about parametric tools, about people that they are looking for a job in parametric design. I have to do a joke. There is also something that asked me, Arturo, can you please do my thesis work? And I don't know how to answer. Maybe we can negotiate that in a way.
Yes.
But there are like really many questions that we got. We don't have time for. I got more than 100 questions, so I selected let's say some of them with probably they are the most interesting also for the audience that we have. And Hamid, if you like, I would like to. I want to read this question from which is about. I think it's very interesting, and probably you are the guy, you are the man that can answer this question, which is why the parametrics, why the parametric design is the future. Like lots of people telling this. I'm reading the question. I would like to say the parametric design is not only the future. I think it's the present. But I would like to say to hear your point of view on that and your answer.
Thank you. Thanks for asking the questions. And yeah, we get a lot of questions from social media, Instagram, Facebook, LinkedIn. So why parametric design is future? Actually, if I change the question a bit from parametric and computational design is the future, I would answer something like, because we will have too much data in our hands. We will have too much data to calculate. So in the future, we will need to design to design something adaptable to more to environment. So we get the data from the environment. So we need a lot of computational powers to calculate and analyze these data for us. So why we need these computational tools? In order to analyze and calculate these data and also to apply them to our designs. For example, we need wind data, we need sun data, we need site data, and we need all these data to collect them, to apply them in our designs. So with analog designing and sketching and just modeling it on a 3D environment doesn't change anything for the future. So that is my point of view for why we need to learn architectural softwares which are parametric, which have the capability of using parametric design tools. That's it.
Yeah, I feel the same. And you know, sometimes people they say that parametric design is only about creating complexity, and my answer is always is the opposite in a way, that parametric design is for managing complexity. And you know, also
Exactly.
I also think that you know, the old story that our brain is powerful but slow, and the computer is a very fast but stupid tool. Actually, I also think today that our brain is able to create and to imagine procedures. It's able to imagine also scenarios and new things. And the computer and parametric tools, they're also able to merge together, to accelerate our visions, to merge them together. And sometimes this kind of crash and this like acceleration can give us some unexpected solution, which is totally consistent with data you were mentioning, but somehow we can come out with something which is unpredictable, and maybe sometimes is the solution. And our brain is able to think and is able to manage small procedure, but we cannot manage all the whole thing together. And so the parametric tools are crucial for that. Can you see me, Hamid? Okay, you were freeze for a while.
Okay. Okay. Actually, to start something like this and to go fully with parametric software, People always ask which software from where we should. And we have a question right now in my notebook that I wrote it from last night's story. D Arch asks, from where should I start learning parametric design and how to understand the concept of parametric design? What would be your answer for this question, Arturo?
Well, my answer is not only about tools, because people, mostly young generations, sometimes they overlap the idea of parametric design with the idea of parametric tools. I mean, our weapons are basically mathematics and geometry. You should start from that. It's not possible to manage computational tools if you don't have a strong knowledge of geometry. In particular, I would say differential geometry. It's important to have some very basic knowledge of coding, of scripting. For example, when I started 12, 13 years ago, more or less, I had zero skills about programming, or almost zero, and like learning a bit of some Python or C# helped me in understanding the basic logic of creating algorithms. But it's very important to say that algorithms, they are not something strictly connected with the computer, but the concept of algorithm is totally linked to our brain, to the human ability to split complex problems into simple tasks. So geometry, once again, mathematics, of course, they help. Kind of attitude in splitting, once again, a problem which is complex, yes, and we need to split it into simple parts. And all those things together, they help you in creating a kind of what I usually call and define computational creativity. So when you master all these things, you are able to invent, you are able to create the good recipes. Later on, when I will talk about Grasshopper, I always use this kind of kitchen and recipe metaphor in order to explain algorithms. You need to understand the tools, of course. It's important to master 3D modeling softwares and also like algorithmic editors. Grasshopper is one of them. Is my favorite one. Is the one that I'm going to explain later on. But once again, to be super simple, I think that geometry, mathematics, and a bit of the idea of how to create an algorithm, they are the most important things. You shouldn't be focused only on tools. What's the best tool for doing something? Is it Grasshopper? Is it Dynamo? Is whatever? It's important to understand the logic which is behind. But in our field, which is architecture or design, once again, probably I'm repeating myself, geometry is the most important skill in a way.
Exactly. So how common is it used in industry? Like people like asking, okay, I learned this software, how I can develop something out of this, how I can use this to like 3D print something. What is the use of parametric tools in the industry, like in fashion, in jewelry, in architecture? Can you just brief that out a little bit for us?
I read something during the Fashion Week in Milano 1 month ago, and someone said something like, the next Coco Chanel will be a coder. And I think that this is a very strong sentence, because 10 years ago, probably my answer would have been different. But today, I think that computational design, the idea of creating objects, not only by modeling objects, but as you mentioned before, like putting together data, combining them, and creating something that, once again, sometimes is unexpected, which is not possible to control just with our hands and with our brain. I think it's a kind of a common ground today. And if you check automotive, for example, you can also see something here on my wall. There are sketches that they come from the real, from the battlefield in a way. And you can see there is a car there is a stadium or a sculpture. I think today every industry is like, probably sometimes they don't understand that they need all this new paradigm, but you can see it in footwear today. You can see it in the new cars, but in architecture, of course, the architecture probably was the pioneer field in computational design. Probably you already gave the answer. Since everything today is based on data, and this is not just a sentence, this is not just captive sentence, but it's something real. Computational design is once again is the present, is not only the future. There are also, for example, in data management, data representation, but I saw and I experienced the use of parametric design in really in many different fields. Also, publishers, sometimes they use like the computational design logic for creating, for example, a book. Let's say there are really many different things, and there is something really important that happened in Italy in the last week. During the last week, there was a problem with doctor tool. Sorry, I don't remember exactly the definition of a piece. They were not able to find on the market a particular piece that was important for save people life, and they modeled and they 3D printed a vital piece that right now they are using for the emergency therapy during the coronavirus situation right now in Italy. Once again, today I cannot imagine, if you really want to compete at contemporary stage of industry, you cannot think of like playing your game without understanding and mastering tools, but once again the theory and the methodology which is behind the computational tools.
That's right. So what do you think this computational and parametric design tools in the past 20 years, how did they affect architecture?
We don't have 5 hours to talk about that. We don't have 5 hours.
You can probably fit it in 5 minutes, but very general overview to this answer.
I think that we basically experienced like a kind of parabola. Everyone can recognize a first stage where everything was like a cosmetic use, the first layer of architecture was involved. When I say first layer, I mean also in terms of communication. The masters, the pioneers, they used parametric design as a way for a new kind of expression in terms of material, in terms of shapes, in terms of geometry. Everyone knows that was shocking. I was a student when let's say the first attempts, but we have to be also I don't know if you know that the expression parametric architecture was born in Italy thanks to Luigi Moretti in 96 more or less, but also before actually the word was used.
Yeah, before that date, he designed a stadium. Like in 1938, it was like with 19 parameters, he designed a stadium.
Absolutely. That was the first time, and those pioneers, they imagined and they understood actually that the idea of an algorithmic approach merged with the computer, that at the time they were existing, but of course they were a niche product and niche tools. And now the following stage was about a cosmetic use of parametric tools, and we all know about that. What is happening today is like this kind of what I was mentioning before. They are a part of our profession. I really, when I go to architecture offices, but also in many companies, I was very liking over the last 10 years of like meeting people from different industries. And it's surprising sometimes that I can see Grasshopper, for example, one of the most famous algorithmic editors out there. And you can see it in many different contexts. The impact in architecture, once again, is like I can see this kind of change from a cosmetic use into a kind of I would like to say invisible use of parametric tools. Invisible is something that which is more deep. Sometimes we can see objects. We had a discussion, for example, when we met in Milano a couple of months ago,
Right.
and we were talking about, for example, the new Tesla car.
Exactly.
And we know the amount of technology work in terms of design that there is behind the simplicity of this car. I think in a way that's the new it's kind of new symbol of what is going to happen. So a deep use of data, a use of computational tools and algorithms in order to to represent something that sometimes is apparently simple. And I see, and I strongly believe that in the future, computational design will help to design better objects, better buildings, better cities. And this is not only programmatic, I think, because if we can use in a proper way the amount of information that they are in real time right now. They are not information stocked in files and they are static. Today, we can really have real-time information from IoT, from sensors, from the internet, and so it can really improve. But we need education, and this is the second important. This is the real mission. People and designers should be educated on that. And I think there is a kind of delay on that because people and students, I can see it in many universities, there are like academias where parametric design, computational tools, and whatever, they are still understood like just a tool among the others. But I think that like the new generation of students, of architects and designers, they should be well educated in the use of data, and they should be able to manage all this complexity in order to solve it and not in order to represent it.
Great. You got any questions?
Yeah, I have something that is I think it's perfect for you, which is, people are also students and young professionals. They are also worried about their future. I mean, there are people that they invested a lot of time and research. And for example, there is a question which is advice for being hired in architectural firm in the field of parametric design. So what are the essential tools and the experience, the background in order to be hired? So this is a very pragmatic questions, but pragmatic question that you probably can tell us something more about that.
Yes, as we talked again in Milan about PA jobs. So I've started working in architecture offices since 2011, and now almost like 8 years I have experience after graduation. If actually it's 8 years, but what we are looking mostly in architecture offices are the people who has the ability to learn, who has the ability to fix things, who has the ability to not getting stuck in one point. So this is very key point for me when I interview with interns, when I interview with architects to hire them. So I value really on these points. So even if you're not even a parametric designer, even if you're a graphic designer, just 3ds Max or anything, or AutoCAD, you need to learn how to fix things. We don't expect from anyone to know anything, but we expect anyone to go and find the answer, to go and find how to solve things. Just but if I want to emphasize on parametric design and how to get hired, you need to know about how to code, how to work with Grasshopper, how to work with Dynamo. You don't have to learn all of them. You don't have to know all of them. But if you're going to specialize in one field of like just Grasshopper or just Dynamo, you need to get specialized in one of those fields. And how to integrate these two softwares, how to work. So if I'm doing something on 3ds Max and it's not something like parametric design, you need to offer how we can parameterize that model, how we can save time by modeling it on Grasshopper, how we can save time by modeling it on Dynamo. And how we can calculate the data over there. And this will save a lot of time for us. Maybe instead of working 3 people on a project on 3ds Max, you can work on projects with 2 people with Rhino Grasshopper. So that would be my suggestion. Also, we started PA jobs on our website, and also we're posting on Instagram and social media about the latest computational design jobs available around the globe. You can check the webpage, and we'll keep posting about the job opportunities. Also, from this event, if you're going to share it on, if our audience going to share it on social media, Instagram, everywhere, just tag Arturo, Hamid, and Parametric page, so we could repost those stories. Thank you.
Yes, and actually, it's a great like service, the one that you are offering, because over the last 5 years I received tons of messages and emails about how to find a specific job in parametric design, and so it was really something that was not out there before your idea. I was also I will also add something, which is it's important to be also transversal in a way. I see like many times people that and young professional and students that they are really focused on just one tool, as you were, Hamid, as you were mentioning before, just one environment or skill. It's important to be able to switch from one to another. It's important to create integration. So this ability also of lateral thinking, which is always important, I mean, and it's not strictly connected with the tools. I think there are always, for example, my practice, my firm today, we are working in different fields. So people that sometimes they would like to work with us, I always ask to be really to have the ability to switch from a shoe design to a stadium to a car and so on. It's also important because the computational designer actually is a kind of new profession to me also, which is something in between industrial design, architecture, coding, data management. Is a kind of new figure. That's why I also think that will be important to have a new kind of education in this field.
Exactly,
And
exactly. It's 5:30. Would you go with the program, or
because one of
the
one of the question was
okay.
What are the concept of parametric design using Grasshopper if we are beginners is one of the questions. And actually the second part of this event is about my idea was to do an introduction, a quick introduction to Grasshopper. We will have 1 hour enough for that. I like to be to give like this introduction for absolute beginners, and also to do something interesting in the second part, also for people with some experience in Grasshopper. So I'm trying to do something which is enjoyable and also can give you really a quick start in Grasshopper if you never used this tool before.
Yes.
So thanks, Hamid.
So how many time we have?
We have 1
Okay.
hour and a half because yeah, from now until 5 p.m.
Okay.
Central
Thank you so
European
much,
time, of course.
Arturo. I will leave this conversation. I will follow the process.
Okay. Thank
And
you so much.
I appreciate your time. I appreciate your effort to make such a webinar. I hope we will keep doing this more with other people as well.
Absolutely.
You joining and me. And goodbye.
Okay. Thank you so much.
Ciao.
And see you soon. Ciao.
See you. Ciao.
Okay, guys, so now I'm going to start the sharing. Let me come back to the... Okay, so I'm running now the application for sharing the screen, and so we can start with this Grasshopper session. Okay, so you should see my screen right now. I just ran Rhinoceros version 6 and Grasshopper. Okay, just 1 second. I'm just like setting up. Okay, perfect. Okay. So this will be a very first introduction to Grasshopper. Grasshopper, as you probably already know, is an algorithmic editor embedded in Grasshopper. In Rhino. In particular, I'm using Rhino 6 right now. Grasshopper is not a standalone tool, but actually is an editor integrated within Rhino. It means that Grasshopper allows us to create geometries, to create objects, and to manage, once again, complexity by writing algorithms without interacting with geometries like we usually do manually in a three-dimensional environment like Rhino, for example. So in general, there is something that I always say, which is the following. Every time we model something into a three-dimensional environment, we basically still use our hands to modeling them. We are using our hands through the mouse, through a particular software, but we are still creating objects using our hands. What we are going to learn today is like creating geometries and managing complexity through algorithms. So an algorithm is a way for getting like particular task or solving a particular problem by splitting a complex set of operation to split a complex problem into a set of simple operations and tasks. Before I was talking about a recipe. If you think about creating or preparing, baking a cake, for example, we need to use a set of things. For example, we need ingredients, first of all. We also need tools for preparing a cake. We need a oven, for example, but we need a procedure in order to prepare a tasty chocolate cake, for example. Now, when you are dealing with algorithm, you basically do the same thing. And the first thing to understand about Grasshopper is the interface itself, which is a super simple environment. In particular, as you can see here, we have this window that works in parallel with Rhino. And it's important to say that you can basically run Grasshopper just by typing the word Grasshopper on the command line of Rhino 6, or in alternative, you can click the relative icon that you can see here, where you can see Launch Grasshopper. So when you launch Grasshopper, you will see this simple window, which is basically divided into two main parts. You can see here this area, which is called components area, and this one, which is called canvas. The components area can be imagined like a shelf with ingredients, once again. So if you want to prepare a chocolate cake, you need chocolate, you need milk, you need sugar, and so on. Basically, we need ingredients. Our ingredients, they are stored within those tabs. They are usually called categories. And so, for example, we have params, mathematical ingredients, vector ingredients, curve, surfaces, and so on. They are not actually buttons. They are like similar in a cosmetic point of view. They are similar to the ones that you can see in Rhino. But actually, if I click here, if I click there, nothing happens because they are not buttons. They don't execute any command. But basically, you can drag and drop those objects onto the canvas, which is basically a kind of kitchen table where we are going to prepare our chocolate cakes, our recipes. And they are like funny and fancy objects. As you can see, you can like drag and drop there. They are different. One of it, they are not the same as you can see here. For example, they are with object with fancy icons. They look like batteries or like boxes. Now we are going to understand what they are and how they work actually. The canvas, which is the area that I showed you before. So, I mean, the central area is not an interactive one. It's not a three-dimensional space. This is just a white table where we are going to create our algorithms. An algorithm, once again, is a procedure and is made using the so-called components. In my analogy, they are the ingredients in order to create our recipes. Now, let's take a look to the components and how they work in order to combine them in order to create proper and working algorithms. Let's go, for example, in the vector tab here. As you can see, every tab has a set of subcategories. So if we go in vector, you can see field, grid, plan, point, and so on. Let's go here in point, and let's click on this guy here, which is called construct point, and I put this object here. Once again, I'm going to use also a tip so you can see the name here. This component is called construct point. This is one of the 100,000 components that you can find in Grasshopper, and every component in Grasshopper does something, generates something. For example, this specific component, if you hover the mouse here, you can see a tooltip which says, for example, this component constructs a point from X, Y, and Z coordinates. In other words, in Rhino, in a three-dimensional software, you can create a point by selecting the proper command and by clicking on the three-dimensional space. Or, for example, we can use this guy here in Grasshopper. In other words, it's important to say that inside Grasshopper, we are going to create the algorithm, which gives us as an output a geometry inside Rhino. So as you can see here, where I can also activate the grid in Rhino. Okay, when I put this guy here, this component within the canvas, you can see this point appearing inside the three-dimensional space, and in particular at an axis origin. So it basically means that this point has 0, 0, 0 coordinates. So once again, if I delete this component and I put it again, so I come back to vector, construct point here, as you can see, we can see a point appearing in the axis origin. Now, we need to understand how component works, then we need to understand the anatomy of a component in order to master the relative like functioning. So basically, we have three typologies of components. Let me write something here so it will be easier to understand. So we have the standard components. This is the first typology. And construct point, for example, belongs to this category. Now, a standard component is an object which is fed by data, so we can put data inside this component. It does something and it generates an output. So you can basically imagine a standard component. We can imagine it like a kind of blender. So we have a blender. It means that you can put ingredients inside the blender. The blender does something, so basically it merges the ingredients, and so we get something which is our output. So we can prepare a milkshake, putting, I don't know, milk, ice cream inside a blender. So we blend the ingredients and we get some output. So the standard components, they work like this. So why construct point is like a blender? Because we can put ingredients inside X, Y, and Z. In this specific case, we can put values like 0, 0, and 0 by default. And so we get an output in Rhino. So in particular, we see a point here. Of course, it's possible to change the input or also the output. So basically, we have this area, which is called input area. And then we have this area, which is called output area. There are many ways for changing data, in other words, to change the ingredients within our blender. One of them, in case they are numeric values, is just using a second typology of components. So we have a second typology. They are called input components. The second category, so once again, they are our blenders. The second category, input components, they can be imagined as a remote control. So in other words, it's a kind of component which doesn't blend data, but just gives data as an output. One of the most important, you can find it inside the params category and util category, is input category is called number slider. So the number slider, this one in our analogy is like a remote control, helps us in like providing numeric values from this component to another input. So for example, I can transfer this value that you can see here. By default, you can see 0.25. I can transfer this value inside this input. How? We can do it in a super simple way by extracting this object, which is called wired. So this wire can be connected, for example, here. So now we have a direct connection between 0.25 and the X input. So what is going to happen here in Rhino? As you can see, let me come back here. If I change this numeric value, I can slide this central grip. That's why this component is called number slider, because you can slide this value. As you can see now, the value ranges between 0 and 1. And so also the point is moving about from 0 to 1 meters, because right now in Rhino, as you can see here, we are having meters as a main unit. So Grasshopper is not something external from Rhino. We are working inside Rhino in a way. And so 1 means 1 drawing units in Rhino right now. So as you can see, we are getting this kind of parametric behavior. In other words, we are changing this parameter, and also this point changes accordingly. We can do the same thing for y and z. We can do it by putting another number slider, and we can connect this one here, for example. By default, as you are realizing, the slider ranges between 0 and 1. Of course, we can set this object, so we can change the numeric range by double-clicking here and by applying some change inside this window. But as I always say, life is too short to waste time in setting parameters like this, and actually they invented, the Grasshopper developers, they invented a new way for kind of shortcut for putting numbers inside the canvas. So for example, if we want to define a point with coordinates, let's say 5, 6, and 8, okay, we can do something super simple. I can double click on the canvas. As you can see, a research bar appears like that, and I can just type 5, for example. So Grasshopper is suggesting us the number slider, so I can click here. And so as you can see, we have a slider which already has 5 as a current value, so I can connect this one here. And as you can see, my point is moving about 5 units according to the x-axis, as you can see here. Then I want 6 as a second coordinate, so double click here, 6 already, and okay. And so we have 6 units according to the y-axis, and once again, double click here, 8, number slider, and here it is, we have 8 as a z coordinate. So we have a point defined in the space, as you can see here. Of course, we can still manipulate the position by moving the number slider in x, y, and z direction. Okay. So let me clean up a bit here. So once again, we have construct point, which is a standard components, which can be imagined as a blender. In general, standard components, they have this kind of layout, this kind of anatomy. We have the input area, output area. In the middle, you can see the just the component's name. It's also important to say that the 3 sliders, they are called input components. Why? Because they just provide values to another component. So basically, they cannot manipulate information. They just provide information to another component. So never forget, standard components. I have to say that the standard components, they are, let's say, the most usual components within Grasshopper. If you click here on our tab, let's say that 80%, also if this is not a real percentage, they belong to the standard components typology. The input components, they are basically stored inside params input, but also when you add plugins to Grasshopper, because Grasshopper allows us to also expand its possibilities by adding new features and new plugins. Sometimes input components, they can be also spread and put within other tabs here. Now, the third typology. And we are talking about the so-called parameters, but I like to call them container components. Okay, so this is the third category. The third category, guys, is like we can imagine them. They are no longer blenders. They are no longer remote controls. They can be imagined like simple boxes They are like empty boxes where we can put ingredients inside. For example, we can put sugar, you can put milk, but we can put inside them curves or surfaces. And it's important to say that in Grasshopper, they are mainly used in order to create a kind of, I always call it like a Stargate between Rhino and Grasshopper. It means that, for example, if I create a point or a line in Rhino, I can transfer it inside Grasshopper. So a super simple example of that is like I can put a point here. So I'm creating the point manually in Rhino. So we are talking about traditional modeling. So I can, okay, let me come back here. Okay, so with the single point command, I put a point here, and I can collect this geometry from Rhino inside Grasshopper. You can imagine the benefits from that. From that, for example, if you want to create, let's say, for example, a building, a skyscraper, starting from a plan created in AutoCAD or in a 2D environment, you can create the 2D or also 3D elements in Rhino, and you can collect them inside Grasshopper. Now, in general, you can find container components inside params geometry and params primitive. You can recognize them by the black hexagon icon, as you can see here. So components with the black hexagon icons, they are container components. And we have, for every kind of geometry, we have a specific one. For example, if you want to collect points, you need to use the point component here, container component. As you can see, the component is orange, is not gray like the first one, because Grasshopper distinguishes uses colors in order to represent some characteristic about data. For example, if you have a component which is empty, since we don't have data stored inside this component, so it appears in orange. A gray component means that it's a component that works properly with data inside. How can we set this point from Rhino to Grasshopper? I can click this one. I can right-click here, set one point. So once again, I right-click this one. When you right-click a component, also construct point, for example, a context menu appears, and so we have a lot of options. It's not possible right now to explain the whole set of features that we have, but we just have to, in this case, right-click the component. We can ignore everything except this one, which is set one point. So as you can see, the Grasshopper interface closes. We can select this point, and as you can see, this component now is it turned gray. It means that we have the points inside. And so we can manipulate somehow the point collected inside Grasshopper. It's important to say that there is a tool that you can find in params input. It is called panel, this one here. By default, it is yellow. I just changed the color in my interface. It looks in general like a post-it. This is very useful for like reading what is happening inside a component. For example, if I connect this guy here, it gives us information about the point generated through this component. So you can see 2, 3, 2, which are the coordinates, of course, that we defined through the number sliders. If I'm going to use, once again, this one, like this, as you can see, we can see a reference point. It does mean that we have a point which is set, referenced from Rhino. The panel is also used for defining numeric values that they don't change, and when we don't want to change our numeric value, in general, we use the panel. I want to show you an example. For example, we have here this point with 2, 3, and 2 as a coordinates, and they are parametric. They are variable. I can change the first and the second, the x and y coordinates. If you don't want to change a coordinate, for example, a specific value, we can use the panel. So you can put the panel here. For example, I want 5 as a value. You don't have to confirm using the enter button, just by clicking outside, and so you can connect the panel here. This is very important. Every time you don't want a variable value that you want a fixed value, you should use the panel as a way for defining the numeric value. Since, once again, life is too short for doing this kind of process, you can double click the canvas. If you remember, in order to put a specific value, you can just write 5 or 6 and so on in order to get a slider. Or you can double click here, quotation mark, and then, for example, 5. I click on panel, and so as you can see, we will have a panel with a specific value set here. So, for example, I can connect 5 here. Okay. I can also delete the panel like this. Okay. Now we have 2 points. The first one was defined by using the Grasshopper component, so construct point. The second point was defined using putting manually a point from Rhino, I mean, using a Rhino command inside the three-dimensional environment. Now, I want to do something, let's say, more complex. Basically, I just want to create a line between this point and this one. If we were just in Rhino in a three-dimensional environment, there is a command which is called polyline. You can click on this one, and then you can select the 2 points and connect them then together. Okay, in Grasshopper we can do something like similar, but without using, once again, without using our hands, but we need a new component. So we need basically a new blender, a new standard component, allowing us to create a line starting from 2 points. So if you go in curve, primitive, here you can find a component which is called line. It creates a line between 2 points. Now, as you can imagine, if you are absolute beginners, we can say that there is a component almost for every task. So there are components that they basically they transfer inside Grasshopper the Rhino commands, but there is also something more. But in general, you can find components for performing every kind of task, more or less. So line component. Once again, we don't have time for describing the whole set of ingredients that Grasshopper gives us, but it's important to understand the main logic. So line is a standard component, is a blender. So we put ingredients, we manipulate ingredients, and we get some output. We have A and B, which means point A and point B. The component is orange, which means that we have a lack of data. We don't have data inside. And so I can start by connecting this one here. Okay, so we define the first point. The component is still orange because we have still a lack of data. We need 2 points in order to create a line. And so now I'm going to connect this one here. Okay, as you can see, we have a line. This is probably the most simple algorithm that you can create in Rhino Grasshopper. This is a line, but this is a parametric line because we can change, for example, the x and y coordinates. So as you can see, we have a line updating. We can also change manually this point because it was defined in Rhino. So as you can see, we are getting a parametric line. It's also important to say that if I click on this, nothing happens because the object generated through Grasshopper, they are a kind of ghost inside Rhino. They are, we can see them, but we cannot use them as a Rhino standard geometry. In order to use them, in order to bake them, this is the proper word, we have to select the specific component that gives as an output a specific object. For example, if I want to use this line, if I want to touch it in a way, I should I have to select my component like this, right click. As you can see, we have also here set of options. It's important to click exactly on the black area, and we can find this option, which is called Bake. If you click on Bake, a context menu appears, allowing us to set a specific target layer, let's say layer number 5. Okay. And as you can see here, okay. Let me go in render mode. Let me change the, okay. Okay. So as you can see here, now this line is a Rhino line. So we still have the Grasshopper output here. So we can still manipulate the X and Y coordinates. And for example, we can bake it again. So bake, I go to layer number 5 again. Okay, and you can do as many bake as you want. I mean, it's not it's an endless procedure, and if you have more complex algorithms, for example, you can create many. You can generate many outputs from the same algorithm. Let me change this one. Okay. Another crucial and super important topic is about vectors. For example, I have this line now, and I want to move it, for example, according to the X, Y, or Z axis. So let me okay. Now, for example, I'm using the move component. So this is the unit Z component. Okay, so for example, okay, with move, I can move an object. This is a, okay, so this is a component allowing us to move an object G according to a specific direction. T means translation vector, and G means the geometry to move. So line can be connected here. Okay, so I want to move this line according, for example, to the Z direction. Okay, so once again, if you want, so I'm double clicking here, move in order to get the move component. and T in order to define the vector. So let me use unit Z. So just clicking on Z gives us the vector unit Z. I can connect this one here. And as you can see, the point is moving, the line is moving about 1 unit because by default, the Z vector uses 1 as a moving factor. So we can put, for example, a numeric value here, like 12. Let's say, and then as you can see, we can move our line, for example, according to the z-axis. We can change, for example, if you want to move according to the x-axis, we can replace this one with the x vector. You just have to right-click here, x, we have unit x, and we can connect this one here and this one here. As you can see now, the movement is happening according to the x direction. If you want to find both move and unit x, y, or z, move, you can find it inside transform Euclidean, and unit x, you can find it inside vector and vector. As you can see here, we have the basic unit x, unit y, and unit z. They allow us to perform like basic movement and operation. Okay. Okay, this was a super fast and basic introduction to Grasshopper. We can do just 5 minutes of 3 minutes of break in order to set up the next stage. Thanks for being with us. Just 2 minutes, and then we can come back here. Okay, here we go again. Okay, guys, so thanks for being with us. And now we are going to do a second step. Okay. Okay, I didn't interact with you so far. I don't know if you can, there are people connected through Click Meeting right now, and also people from YouTube. I want to say that I'm sorry that everyone, the Click Meeting room is not large enough for all of you. I know there are people that are following us on from YouTube. Okay, can you hear me, guys? If you can write on the chat in Click Meeting. Okay, perfect. Okay, amazing. It's important to say that we will also, later on, we will update on my YouTube channel the complete and high quality recording of this session. I hope the quality is good, but we are really doing a huge effort in order to do the live streaming. There are a lot of people connected, so and it's a moment where many people are doing like online lessons and webinars. So I really hope the connection is fine and stable. After the first introduction, once again, this very simple introduction to Grasshopper in order to introduce like absolute beginner to the use of the Grasshopper's interface, I want to do something which is more complex, which is, let's say, more enjoyable for people with some experience, but that also the absolute beginners can follow. So my idea is to show you a way for creating a kind of complex facade or geometry like the one that you can see here. And we are going to start with super simple rectangular surface, the one that you can see here. Okay, and one single line, this one. Okay, in Rhino, if you don't have experience on that, you can right-click here. You can create a rectangular plan, no matter the dimension, and just a single curve, which is a straight line. So nothing like complex or difficult to do. Once again, our final goal is creating this kind of complexity with a particular procedure which uses iteration. So we can create a simple procedure that Grasshopper and computer is going to repeat with a set of iterations in order to get this kind of like regulated, this kind of ruled, controlled complexity. So we have this line here. As I said before, we can load geometries from Rhino to Grasshopper using this parameter, this container component. You can find it inside the params geometry. We have the curve component, this one. So I click on this one, right click, set one curve, and I set this curve here. Okay, perfect. Now we don't have so much time for explaining what I'm going to say, but every time you set a curve or a surface from Rhino to Grasshopper, it's important to right-click the component, and you need to set this option, which is called reparameterize. You need to trust me right now about that. If you already have some experience, you know why I have to do this thing. In order to simplify the process, is basically a way for parameterizing this curve from 0 to 1. For example, if I'm going to use a component which is called evaluate curve, this one, I can connect this one here. This is a standard component. This component needs a curve, and we can define a parameter which is a value between 0 and 1. So for example, let me put 0.5. So double click here, 0.5. I connect this one here. So I can play with this slider from 0 to 1. Okay, so if you parameterize with this option that I showed you before, you can walk along your curve by sliding the slider between 0 and 1. Okay, like this. Okay, now I'm going to use a new component which is called the line SDL, a new standard component. New standard component allowing us to define a line starting from a start point S. So I want to start my line from this point, which gives this output that you can see here. Okay. We need to define a direction. Now I want to create a vertical line starting from this point, something like that. So Y, if you remember, we can define the unit Y direction. So this one is connected here. Okay, and L is the curve length. So let me use like arbitrary value, like 200. That should be in scale with my drawing. Okay, so as you can see, we are creating this line. Of course, you can change the line dimension like this. So let me do 200. Okay. If you want to create also the symmetric part according to this point, there are no options if you want to do it directly here, but use another standard component which is called extend curve. As you can see, of course, if you are if this is the first time that you are using Grasshopper, probably you are overwhelmed by the amount of components that we are using, and also you're probably wondering how I can like memorize all of that. But this is absolutely not a problem, and the daily use of Grasshopper will help you in memorizing the possibilities that like components they give us. For example, extend curve allows us to extend a curve like this, starting from the L0, which means the start point, or the end point. So if I'm going to use the same number slider that I have here, so here we have 200, and I'm going to connect this one to L0. As you can see, nothing happened because also the L1 value should be defined. We don't want to extend our line here, so we can just put 0 using the panel. If you remember, if you want to define a numeric value using the panel, you can double click here, quotation mark, 0. Here it is. So we have 0 here, and this one goes here. Okay, so we have a line defined in Rhino. This one is created in Grasshopper, and as you can see, this is symmetric around the point defined by the evaluate curve component. Of course, if you come back here, you can play with this parameter, and you can walk along the curve. Okay. The second thing that we can do is also playing with this the curve orientation. So basically, we can rotate this line around the point here. How? Basically, we can play with the direction that we are here, and we can rotate it. If you double-click the canvas, if you want to rotate something, you can just type rotate, and as you can see, we have this component which is called rotate a vector around an axis, because this one is a component that rotate vectors. We are playing with a vector, so I can put this one here. Okay. X, the second input, is the rotation axis. Now I want to rotate my line around an axis which in a way is perpendicular to my screen. So if we have X and Y, this axis would be the Z axis. So double click on the canvas, Z, unit Z, and I can connect this one here. Finally, A is the angle, which by default is expressed in radians, but nobody likes radians. So we can right click here. This is a joke, of course, but you can switch from radians to degrees by right clicking directly on top of the A. You come back here in degrees. And finally, give a numeric value like this and like that. So as you can see, we can rotate our line this way. If you want to rotate, like, let's say, clockwise, we need to change this numbers sign. But in alternative, we can also use a component which is called negative, which basically is a multiplication by -1. This one is connected here. And so we can rotate like that. Okay, now we have, so this slider in order to flow along this curve like this. And then we have this slider for performing the rotation. This is once again, it's a fixed value, it's a specific value. In this moment, it's 38. But Grasshopper allows us also to generate like random values, for example. So I can do like this. I delete this guy here. There is a component which is called random. Now, don't be afraid, it's a super simple topic. I can connect a panel here. By default, if I just put the random components on the canvas and I connect a panel, you can see 0.77. Okay, so 0.77 because by default, random generates a random value which is between 0 and 1. And it generates just one value because inside this input we have 1. We can change, of course, this numeric domain by using a component which is called construct domain. So let's go here in construct domain. No, sorry, not this one. Okay. This one goes here. And for example, I want a numeric domain between 10, I don't know, 220, for example. Okay. As you can see, the random component picked just one value, because here we have 1 and we won't touch this value here, the n value, so just one value. And as you can see, we also have a third input, and which is called seed. This input allows us by connecting a generic value here to change the random value generated by this component. You can imagine this one like, like a slot machine. You just play with the you just play with the button, and so you generate different values. Okay, but they are always between 10 and 220. Okay. So that said, I will connect random to negative. And so we have a specific like rotation angle, which is random and is generated by this value here. So once again, we can move this line here like this, and we can also rotate with a random value like that. Now, we should take some benefit from the computer and from this kind of algorithmic environment. So I want to create an automatic procedure, because we always have in mind this geometry, which is in a way, if you take a look at it, basically it's like a movement and rotation of different lines. We can create an automatic procedure for creating this kind of effect, starting with this very algorithm. So let me change this one a bit. I'm just moving it like this. And we basically have two sliders that control the whole thing. So the one for moving the line and the one for creating the rotation. Okay, now in Grasshopper, basically it comes from a plugin which is called Kangaroo, but I think it's available also within other plugin set. There is a component which is called counter. The counter allows us to create a value with changes over time, along with two other components. One is called timer, and the second one is called Boolean toggle. Okay, it's super simple, don't be scared about that. Basically, I need to connect the timer here. So for example, you have to extract this strange wire, because this one is different from the other that we saw before, and you can connect this one directly to the counter. And as you can see here in Windows, kind of timer block appears. So as you can see, we can control this one. We can turn it on and off also by clicking from the Windows bar. The toggle is a toggle that allows us to switch from true to false, as you can see here. True means that our counter is reset. If I turn this one on, as you can see, we have this counter that works like counting from 1, 2, 3, 4, 5, 6, 7, and the update happens every 1 second. We can also double click here, so we have the reset, right click, interval. For example, we can change, and we can put, for example, on, I don't know, on 13 milliseconds. As you can see now, it's way faster. Okay. Now I want to use this kind of system in order to control my first slider. So let me delete this one. Of course, if I'm going to connect directly this one to this one, I will get something like this. Okay, as you can see here, we have this kind of super fast movement and acceleration. So we can, for example, we can divide in Grasshopper. If you double click the canvas and you click on the division button on your keyboard, you can select the division. You can also find it in math operator. I'm going to divide the value coming from the counter. Let me divide it like 33, for example. And this one is connected once again here. I get rid of this one. Let me, okay, try to be super organized in order to, okay. So basically I'm using a timer in order to inform this numeric value, and so in order to move this geometry here. Okay. As you can see, it also goes over my line, but this is not a problem. Okay, so this is the first movement that we are automatizing in a way. Another thing that I want to do is like with this same counter, I want to change the random seat in order to generate like random rotation values when I trigger my counter. So once again, okay. So with just one counter, I can here filter by the division, I can do this kind of movement and also a random rotation thanks to this guy. Okay, now this is funny, nice, but I don't see anything. I mean, I don't see this effect. I cannot see this kind of effect right now. Why? Because we basically need to record the output coming from this movement in a way. We need to record every single position. So Grasshopper allows us to have this kind of, let me use, for example, the record component, which is called data recorder. And so I'm going to connect this one here. Okay, let me start again this one. Okay, now as you can see, we are actually recording all the movements this way. If I double click here, as you can see, the lines generated, they are still there. So you can go back to the data recorder and you have to click on X if you don't want to see them anymore. We can also do something like this. We can also move the data recorder here. So we have all the controls in the same, let's say, environment. Okay, so once again, okay, so I can click on this one. Something which is very interesting is that I used one line here, but we can use also a second line, for example, that I can create using the polyline feature in Rhino. So here, where we collected the first curve, we can actually collect two curves. So right-click, set multiple curves, and I'm going to select both. Okay, so here we have, once again, right-click, set multiple curves, and I selected this one and this one. Now I'm double-clicking on this, once again, on the trigger, and you can see this effect. Okay, X in order to delete everything. And so double-click here. I will show you the whole algorithm in order to, this is a kind of overview. Okay. So let's do something like this. Okay, they are running. And then I click on, I double click once again on my toggle in order to stop the movement in a way and the curve generations, the curve generation. Now we can do something interesting. For example, let me move this one here. Okay. Something that we can do is like using once again the extend component that you saw here. You can use it once again, extend curve. We can connect this one like this. And let's use like, I don't know, 370, I don't know, something. So I want to extend both, not both, sorry, but the whole set of curves in L0 and L1 direction. Boom, like this. So we are getting something which apparently looks like a mess. Now, in Grasshopper, it's important to, if you just started today, it's important, for example, as you can see here, we have 1 point and still 1 point because it comes from the first output that we had, for example, here. and we see the output from line, from extend curve, and so on. Now we just want to see the output of this component. So we can zoom out. I can select everything, right click, and I select preview off. So like this, I'm sure that I'm working only on the preview, on the output of this component here, extend curve. So if I click on this one, preview off, as you can see, we don't have any kind of output on the Rhino interface. Select this one, right click, preview on. Okay. Something that, for example, we can do right now, we can also extend a bit like this. Okay. Okay. If you go in intersect region, you can find a component which is called trim with region. And I want to trim those curves using a trimming region which is defined by the surface frame here. So curve component, right click, set one curve, and I have my frame here. This one goes to region. And apparently nothing happens. But if you turn off the preview of this one, you also turn off the preview of this guy here, and you apply another curve component. Okay, as you can see from here, we are selecting all the curves outside the surface, and with this one, we are selecting all the curves which are inside the surface. And you can still play with the other. So, for example, something very simple that you can do at this point, for example, is like we can use a component which is called surface split. We can select the surface from Rhino. You can see here. I'm connecting the surface here and this one here. Now, it's difficult now to synthesize this topic, but there is an option that we have to do, which is called flatten. You have to select this geometry, right click, and you click on flatten. Okay. I'm turning off the preview on this one. And now we basically split the surface into a set of pieces using this set of curves all together. Just for displaying the output, you can scale, for example, those geometries. So I'm scaling with the scale component, calculating the center of each piece using a component called area, and this one. As you can see, area is finding the center of each individual piece. This one goes here. I'm selecting those, right click, preview off. And then, for example, 0.9 as a scaling factor. F define the scaling factor of our geometry. Once you have this, we can, for example, go in a perspective mode. And we can extrude, the extrusion logic that you have in every like modeling software. So I want to extrude those curves according to the Z direction. About, let's say, I don't know, like 6 units. It's a bit heavy. Okay, and then we have this result. Now, for example, we can, if you want to see this is still a ghost, it's a preview from Grasshopper. If you want to bake it, you have to right-click this one, bake, default. Okay, let me turn off the preview of everything right now, and I go in Rhino. Now this is a set of Rhino geometries. Let me go, for example, in by right-clicking here, Arctic mode, and we got this kind of complexity. And it's interesting because we just started from one line and one point moving along this line. But this is not exactly the output that you saw in the picture before. It's not the same, but you can start from the same thing. Okay, let me change this thing. Let me come back in the top view. Okay, so if you want to get exactly this kind of output, we need to change the final part of the algorithm, and there is something, let's say, more complex to do, but nothing that I'm like speaking to the beginners that you cannot understand. We just have to change the final part of the algorithm. So I can freeze this part. You can select everything, right click. You can disable this set of components. So they stay there, but they are not working. They are sleeping. And then we can start from this set of this component here and this set of curves. Let me just change it a bit. Okay. And I'm going to use a component which is called offset curve. So allows us to, if I focus actually on one line, as you can see, if I use offset, it's offsetting in one direction. I can use 1 as an offset distance. Okay. And then I'm going to do another offset with a negative value here. Okay, like this. Okay, so basically now I'm going to turn off this one. We have an offset in both direction, and we can control it with this slider. Okay. Now we started with one line, then I did the first offset, then the second one. And now I want to create a surface between the offset curves. We can do it with a command which is called loft. But we need to gather them together with a component which is called merge. This one goes here, this one goes here, and I can connect this one here. As you can see, this is very powerful because since the procedure works, it works for the all set of lines, all set of couples in a way that we have here. Okay. Now the loft is a set of surfaces. Okay, I can simplify a surface like this. Now, as a second step, I want to extract the wireframe, which consists in 4 lines, which is the surface frame in a way. There is a component which is called wireframe. Okay, so wireframe, if you have a surface, gives you 1, 2, 3, 4 lines, and we want to join them together. The proper component is called join curves. Now you cannot see actually the benefits from this procedure, but basically they are now from a set of surfaces, we got a set of closed polylines that are our surface frames, basically. Then I need to flatten here. You have to trust me. It's not possible in a few seconds to explain why I have to do this, but it's an operation that we have to do at this point in order to have the individual like polylines frames in order they work to individually. And finally, I can use a component which is called region union. You can find it in intersect shape, region union. And this one does the magic in a way. Let me connect this one here. It takes some time because it's a super complex procedure. Maybe we have to simplify the starting input, because now basically this component is performing the union of all those regions. Okay. As you can see, if I turn off the preview of join curves, this component really did the magic, because as you can see, they are now one single piece, as you can see. When I see one single piece, actually, the region, they are actually blended together. Now, another possibility is to create one single surface, which is a trim surface, inside this complexity. Okay. Use a component which is called boundary surface. It will also take some time now. So basically, this component boundary surface creates a flat surface if you if you have a closed set of lines and planar, a closed and planar set of lines. The procedure is a bit slow also because my computer in this moment is also like performing the streaming and the YouTube streaming and the click meeting streaming, so it will take some time, but it's a straightforward like procedure. Okay, we are almost there. Okay, so as you can see, we have a single surface right now. And of course, we need to get rid of the part which is outside our geometry here. So in order to do that, with our curve component, we can set once again this curve here, which is our frame, and we can create a pipe around it. Pipe is like if you have a curve, it creates a kind of cylinder around it, and you can also close the relative ends. So you can right-click here, and you can click on flat in order to. We are basically creating a pipe in order to create a cutting frame and getting rid of all the piece of surface which is outside this frame. Okay, so there is a component here which is called trim solid, we want to trim the surface using the pipe as a trimming geometry. Once again, it will take some time. Okay. Now I'm going to turn off the preview of this one. And if I connect a panel here, as you can see, we are getting two surfaces, the one outside and the one inside. In Grasshopper, if you have a set of items, item 0, item 1, and you want to select one of them, we basically want to select this one. There is a proper component, which is called list item. Need to select the number 1, so I put 1 here. I turn off the preview of this one, and I'm getting this guy here. Let me turn off the preview. We can also, let's go to perspective. I can extrude. Direction Z. Okay. Let me change the extruding like factor. Okay, and finally, we can bake this. Okay. And as you can see, we are getting something which is absolutely similar with the same like generation logic of the thing that you saw in the picture. I can also turn off the preview of this one. This procedure is not, let's say, static, but you can create many different geometries. So let me come back, for example, here. Now I'm disabling the second part of the algorithm, turning on again the data recording. I'm clicking on the X, and for example, we can add, like different lines, for example. So I'm going here, set multiple curves. Just 1 second. So I'm selecting many curves like this. Okay. Maybe we can activate the second part of the algorithm, so in order to see the output of this one. Or we can do something completely different, like changing the typology of curves. For example, we can start with 2 circles. So set multiple curves. And this procedure will give us something completely different. Now I'm just like stopping. So you can create a super complex network with some logic behind, or let me change again. So every time you change something, you have to click on the X in order to delete it. Or I can create a rectangle inside. Set one curve like this. So as you can see, we can apply, and we can use this kind of procedure in different ways in order to get different output. So, well, that's it. I think that you enjoyed this second part, which is kind of, let's say, intermediate lesson in terms of let's say level or complexity. I hope that everything went well in terms of connection. Let me come back to the chat here. So I'm end the sharing. Okay, let me come back to the. Okay, now you should see me. I really hope that the streaming was okay. We really tried our best in order to keep the connection stable, in order to also to give the opportunity to have people also on YouTube. As I told you before, this room was intended only for 1,000 people, but we had many people more than this. And I hope that that connection was good. Anyway, we are going to upload, let's say, a high quality version on YouTube on my channel. So if you missed something, if the connection in your country was not good enough, you will see, and you will have the opportunity later on to rewatch everything in a good quality. Thank you so much. I know there are people from US, Brazil, UK, Australia, and there is someone that is going to sleep right now, or people that just woke up. This one was really the idea of the intention of staying together with you guys is really is a critical moment for everyone, and it's important to share. It's important to stay together and give a kind of optimistic, once again, an optimistic vision. And parametric design, once again, in parametric design, there is a convergence of passion, and the number of people connected right now is demonstrating the affection and the passion that you are for this kind of idea. And not only, we are not only talking about tools, but I can see the passion and efforts and all the research that you are putting. So thank you so much. I don't know, we will probably organize new events in the close future. I wish you a good day, and once again, thank you so much for staying with us.